This is the 3M Dynatel 2573ID Advanced Cable, Pipe, and Fault Locator. It is rugged, water-resistant, lightweight, well-balanced, dependable, and easy to operate. This chapter will cover the basic operation of the 2573ID Cable, Pipe, and Fault Locator. We will include information about the transmitter and the receiver. To familiarize you with the operation of the transmitter, let's look at the functions of each key on the transmitter keypad. To check the battery level of the transmitter, press and hold the off key. The battery level will be displayed. OK and a solid tone indicates a fully functional battery. If low appears on the display and there is an audible beeping tone, this indicates that the batteries need to be replaced. When two dashes appear, or there is nothing on the display during the battery check, the batteries are fully discharged and need to be replaced. The second key of the transmitter is labeled with icons representing three different functions of the transmitter. The first icon is the omega sign, which represents an ohmmeter. When the second key is pressed once, the transmitter will go into ohms mode. Ohms mode is indicated on the display by a flag over the ohms icon. The transmitter will operate as an ohmmeter that will measure resistance between the red and black leads of the direct connect cable. The second icon on this key is the fault locating icon. If the second key is pressed again, the transmitter will go into fault locating mode. When in fault mode, there will be a flag below the fault icon in the display area, and the frequencies 577 and 33K will flash alternately on the display. The third icon on the second key of the transmitter is the tone icon. When in tone mode, a flag will appear below the tone icon. The transmitter will produce 577 Hz and 200 kHz simultaneously. These locating frequencies will alternately flash on the display. The third key on the transmitter is the trace key. This key is labeled with a locating icon. When in cable locate mode, a flag will appear below the cable locate icon in the upper section of the display. The trace key, when pressed repeatedly, will cycle through all available transmitter frequencies: 577 Hz, 1 kHz, 8 kHz, 33 kHz, 82 kHz, and 200 kHz. When all is displayed, each of the following active frequencies are transmitting simultaneously: 577 Hz, 8 kHz, 33 kHz, and 200 kHz. The output key of the transmitter will adjust the output power of the unit between normal output, 1/2 watt, to high output, which is 3 watts. Normal output is the default output power each time the unit is turned on. Normal output is indicated by no flag over the output icon. When the output key is pressed, the output power is set to high output, or 3 watts. This is indicated in the display by a flag above the output icon. If your transmitter has the 12-watt option, an external jack will be to the right of the output jack. In order to achieve the 12-watt output, an external power source is necessary. When using an external power source through the 12-watt jack of the transmitter, the alkaline batteries of the transmitter are bypassed. All 12-watt units come with a 50-foot cigarette lighter adapter cable. This cable is plugged into the cigarette lighter of your vehicle and into the 12-watt jack on the transmitter. When this cable is connected to the transmitter, all three output levels are available on the transmitter: normal output, 3-watt output, and 12-watt output. When the transmitter is in 12-watt mode, the flag above the output icon on the display will flash. As an alternative to the cigarette lighter adapter cable, 3M offers a rechargeable battery as the external power source. The rechargeable battery is plugged into the 12-watt jack. This rechargeable battery will bypass the alkaline batteries that are installed in the transmitter, thus allowing you to save them for emergency backup. All three levels of output are available while using the rechargeable battery. Now we will cover an overview of the receiver and its functions. Power up the receiver by pressing the on-off key located in the lower left corner of the keypad. The unit momentarily displays the model number of the receiver and the battery level. Pressing the menu OK key in the lower right-hand corner of the keypad sets the receiver to trace mode for locating cable or pipe and displays locate options. Displayed options include ID marker templates, writing mode options, and setup screens for configuration of the unit. Configuration settings include clock, language, depth units, marker and data frequencies, COM settings, and help files. The OK portion of this key functions as an acknowledgement or enter key when adding information or configuring the receiver. The volume of the receiver can be adjusted up or down by pressing the arrows located on the left side of the screen. The 2573 ID is equipped with a 2-level backlight that can be toggled between low, high, and off by pressing the key to the right of the screen. The yellow keys below the screen are the command keys. Their functions are defined in the display above each key. These commands will change depending on what screen is being displayed. For example, from the main locate screen, press the second command key labeled Cable Pipe to enter the cable pipe locating mode. You will notice that the command keys are now labeled Frequency, Mode, and Alert. We will discuss each of these later in the video. We are now viewing the cable locate screen. In the middle of the screen is a numerical value called the signal level. This is a measurement of how much of the transmitted signal is actually being detected by the receiver. The signal level will be at its maximum when the receiver is directly over the target path. The bar graph is another tool for indication of target path. When tracing the conductor path, the bar graph should close when the receiver is over the target. The bar graph should open when the receiver is moved off path. When the bar graph is not operating in this manner, the gain needs to be adjusted. Adjust the gain up if the bar graph is open or not closing over the target path. Press the gain down key if the bar graph is remaining closed and unresponsive to the target conductor. The relative level of the gain setting is displayed as a percentage in the right-hand corner of the locate screen. The audio level of the receiver can be adjusted with the volume key. When pressed, it will toggle between off, low, medium, high, and expanded mode. These levels are indicated in the top right portion of the screen with the speaker icon. Also on the locate screen, above the bar graph, you will notice 2 directional arrows. These arrows indicate the direction of the target path. When the receiver is on either side of the target path, one of the directional arrows will appear, indicating to move the receiver toward the left or right. When both arrows are lit, the receiver is on the target path. Across the lower portion of the screen are the command key labels. The first key is labeled Frequency. This is the button that you push to set the frequency that the receiver will detect. When the frequency button is pressed, the command keys are now labeled Active, Power, Passive, and Auxiliary. These are groups of frequencies the 2573 ID is capable of detecting. The active group includes up to 6 active frequencies that the transmitter will produce: 577 Hz, 1 kHz, 8 kHz, 33 kHz, 82 kHz, and 200 kHz are available. If you are using the transmitter to locate your underground utility, you would select the frequency that is being sent by your transmitter. Press the first command key repeatedly until the transmitted frequency is displayed. If you are looking for a frequency that is generated externally, for example, if you wanted to detect 60 Hz that is generated by electrical lines, press the second command key labeled Power until 60H is displayed. This is the harmonic frequency of 60 Hz that is used to detect power lines without the use of a transmitter. Please refer to the operator's manual for examples of applications for all the frequencies available on the 2573 ID locator. When the correct frequency has been highlighted, press the OK key to return to the locate screen. Notice that the frequency you selected now appears above the first yellow command key. The second command key in the locate screen is the Mode key. This key allows you to select the antenna configuration of the receiver. The mode key will scroll between directional peak, directional null, special peak, and induction peak. Most of your underground locating will be done using directional peak. Trace View mode, or T-View, provides an intuitive mapping display showing the utility path utilizing dynamic directional arrows and a path indication line. The cable is displayed on the screen with a directional arrow pointing the direction of the cable. If the locator cannot draw the cable, then the screen will display a rotate receiver icon. If the locator is more than 45 degrees from the cable path, the receiver needs to be rotated. When the path of an underground utility has been pinpointed, the depth to the conductor can be measured by placing the tip of the receiver on the ground and pressing the depth key. The depth of the target conductor is displayed on the left portion of this screen. On the right side of the depth screen, the relative current of the target conductor is displayed. This can be a very valuable tool when determining the target path in congested areas. Further information about relative current is included in the Advanced Techniques section of this video. There are two methods available to measure depth. One is the one-shot method, in which the receiver calculates the depth of the target for 3 seconds and then displays the value on the screen. By pressing the first command key, labeled one-shot, you can change the depth measurement to continuous, indicated by the command key now being labeled live. This measurement method will track any change in distance from the receiver to the target conductor by making continuous depth measurements. Press the OK button to return to the locate screen. By pressing the menu key on your receiver and the setup command key, you will be able to edit different configurations of your receiver. The setup function allows you to choose the units of measure for depth readings and the language of the receiver. You can select the types of EMS markers that you would like to find. You can also enable and disable locating frequencies from this setup menu. This is also the area in which you configure the RS-232 port to communicate with a computer or a handheld GPS unit. The RS-232 port is located on the bottom of the receiver head. In this same area is an 1/8-inch jack for headphones, and a 1/4-inch jack that is used for connecting the A-frame used for fault locating, or a dynacoupler for cable identification. Also for telephone application, a standard toning coil can be plugged into this jack and used for aerial fault locating. Locating is a combination of science, technique, and experience. This video will explain the technical principles and apply them to the skills required for basic underground locating. The most critical concept to acquire for underground locating is the principle of signal path. You must create a complete circuit for the transmitted signal to follow. This circuit depends on 3 components: the target utility, or metal conductor, the physical ground, or dirt, and the grounding device, or ground rod. Each of these components must be connected in order to form the circuit or signal path. When you are tracing a buried utility, the transmitter sends a signal through the target conductor. The far end of the target conductor is connected to the ground, or grounding point. The signal then returns through the dirt, back to the ground rod, and the black lead of the transmitter. The signal creates an electromagnetic field around the target conductor. The receiver detects this field, allowing you to trace the path of the conductor. All locating signals use the soil for the return path of the locating circuit. There are 3 ways to introduce a signal onto the target facility. The first is by directly connecting the red lead of the transmitter to the target facility, and the black lead to a ground rod placed in the earth. The second is the clamp, or dynacoupler method. The third is the induction method. This method uses the internal antenna of the transmitter to generate a magnetic field onto the conductor with no physical connection. Direct connection to the target facility is the most accurate method for utility locating, so we will concentrate on this method for this training session. The transmitter offers several different frequencies: 577 Hz, 1 kHz, 8 kHz, 33 kHz, 82 kHz, and 200 kHz. Using the direct connect method allows you to determine the quality of the signal path circuit. This information can help you choose the best frequency to apply to the target conductor. Connect the transmitter to the target conductor and measure the quality of the signal path circuit by pressing the ohm key on the transmitter. A flag will appear on the lower left side of the display, indicating that the transmitter is in ohms mode. The resistance of the tracing circuit will be displayed. Based on the quality or resistance of the signal path, you can choose the optimum frequency for your application. Here is a chart you can use for selecting the optimum frequency. In the previous example, the resistance of the signal path was 1K. Based on the reference chart, the optimum frequency for this locate would be 577 Hz. You should always select the lowest frequency applicable to the resistance of the signal path. Using the lowest frequency is good practice because the lower the frequency, the less chance of bleed-over signal to adjacent facilities. If the resistance of the signal path is greater than 10K, or if the ohm meter displays OL, this could be an indication of an open line or that the return path through the ground is very marginal or non-existent. You should attempt to improve the condition of the signal path. Refer to the section Advanced Application Techniques for suggestions on how to improve your ground. When using the direct connect method, the transmitter current level will alternately flash with the selected frequency on the display. Make a mental note of the transmitter current level before you start locating the target path. To help verify the target path, compare the transmitter current level to the current measured by the receiver on a suspected target conductor. If low is flashing alternately with the frequency, the signal path circuit is incomplete or inadequate. The far end return to earth may be missing. Verify that there is a return to earth on the far end of the target conductor, and then measure the signal path resistance again. Once a good signal path has been created and the correct frequency applied to the target, the next task is to detect the signal with the receiver. Turn the receiver on by pressing the power key. From the main locate screen, select Cable Pipe. The locate screen will appear on the receiver. Press the first yellow command key labeled Frequency repeatedly until the transmitter frequency is displayed above this key. Press the OK key to return to the locating screen. To select the locating mode or antenna configuration of the receiver, press the second yellow command key labeled Mode. Repeatedly pressing this key will toggle the receiver between directional peak mode, directional null mode, and special peak mode. Most of your locating will be done in the directional peak mode. In directional peak mode, the receiver uses all 4 of its peak antennas to pinpoint the target path. The numerical signal strength in the middle of the locate screen indicates the actual strength of the transmitted signal that is reaching the receiver. The point at which this numerical signal is the highest value indicates the center of the electromagnetic field or the target conductor. The bar graph should open when the receiver is off target path and close when over the target path. If the bar graph is not responding to the target conductor, adjust the gain by pressing the gain adjust keys. In addition to the signal strength and the bar graph, the audio response of the unit will increase as you get closer to the target path. In directional peak mode, the receiver's middle crossbar detects the rise and fall of the electromagnetic field surrounding the target facility. This crossbar contains the antennas that operate the directional arrows. As the receiver approaches the electromagnetic field from the left of the target path, an arrow will appear on the locating screen pointing toward the right. It is detecting the rise of the electromagnetic field surrounding the target conductor. As the receiver crosses the path of the target conductor, the arrow pointing to the left will appear, indicating that the target has been passed. The crossbar is now detecting the fall of the electromagnetic field. The numerical signal level should be at its highest value, the bar graph should be almost closed, and both arrows displayed when locating a target with an undistorted electromagnetic field. See Advanced Application Techniques for information about measuring the symmetry of a locate signal. To verify the target path, measure the depth to the conductor. Place the tip of the receiver on the ground and press the yellow command key labeled Depth. The depth of the conductor will appear on the left-hand side of the screen. It should be the value that you are expecting to see when locating this particular utility. On the right-hand side of the screen, the relative current of the conductor will appear. If you are locating a single conductor using the direct connect method and are on target, this value should be very close to the relative current that is flashing on the transmitter. You can save this depth and current reading along with 4 others for future reference. Simply press the Save command key while in the depth screen. To return to the locate screen and continue marking the target path, press the OK key. When you arrive on the job site, plug the direct connect leads into the output jack of the transmitter. Connect the red lead of the transmitter to the target conductor. Place the ground rod as far away as possible from the suspected cable path at a 90-degree angle. Connect the black lead of the transmitter to the ground rod. Verify the battery level of the transmitter by holding down the off key. Press the ohm key of the transmitter and measure the quality of the signal path. Based on that measurement, select the lowest applicable frequency by pressing the trace key until the frequency is shown on the display. Remember to note the relative current level alternately flashing on the transmitter display. Turn the receiver on by pressing the power key. From the main locate screen, select Cable Pipe. Set the receiver's frequency to match the frequency being transmitted by pressing the yellow key under Frequency repeatedly until the transmitter frequency is highlighted and displayed above this key. Press the OK button to return to the locate screen. Most of your locating will be done in directional peak mode, so press the second yellow key labeled Mode repeatedly until DIR PK is displayed above the Mode key. Begin a 360-degree sweep around the access point where the transmitter is connected, keeping your back toward the access point. This circle should extend just beyond the radius of the ground rod location. Bear in mind that the target conductor should be traced back into the access point to complete the locate. Watch for the reverse of the directional arrows, bar graph to close, and the signal strength to increase. This will indicate that you have crossed a signal. Complete the full circle, return to each point that you detected a signal. Pinpoint each signal path and place the tip of the receiver on the ground and measure the depth of the target line by pressing the depth key. Compare the relative current of the targeted line to the relative current that is flashing on the transmitter. Verification of the target can be made if the depth of the conductor is as anticipated and the relative current measured on the target path is similar to the transmitter's relative current level. Trace the target conductor using the bar graph, signal strength, and directional arrows. Stop occasionally to verify the target by measuring depth and relative current. Follow the target path to a logical termination point for final verification of the target utility. The 2573 ID fault locator